impression and my eye reacted.
Oh, really?
Yeah.
Oh,
Yeah, it's a little bit red,
Yeah.
but it looks nice. Don't worry.
Yeah, it looks like I was in an MMA fight or something more dramatic.
there you go. You should have seen the other guy.
You should have seen the other guy. Yeah.
But in the city, it's cold, right?
Pardon?
It was cold.
Yeah, it was, now the temperature difference isn't so big.
Yeah,
I live in Praia de Barra.
Yeah, it's what, 18 degrees?
It was 18, yeah.
Okay. That's about the same as in Los Angeles.
Yeah, yeah. We have a fairly similar climate to more or less the whole north-south of California.
Yeah, yeah. That's what I noticed.
Silence, please. Merci, Google. 1 minute.
It's not going to be easy like that. I welcome to all the attendants of this exciting Tiny Lab Talk, which is one of the events in scope of the World Space Week organized by the University of Aveiro. It is a great pleasure to introduce our guest. Daniel Olivas was born in California and joined NASA in 1998 and performed a total of 5 spacewalks during STS-117 and STS-128. Our other guest is Rui Moura, which is an alumnus from the University of Aveiro. He's a professor in University of Porto, and he has been training also for suborbital space crew in US since 2016. I'm Rute and André from Physics Department. I'm also vice-director of CICECO, Instituto of Materials, and I would like exactly to start by the academic background. And I would like to ask a question. Maybe I will start by Daniel to ask you, to what extent did you feel that your university education in science and engineering was fundamental for being selected as an astronaut, and also as well as when you performed as an astronaut?
Well, first off, I want to thank the invitation from the university to come and speak to the campus and the people of Aveiro. It's my great pleasure to be here. So my education was actually not accidental as much as it was something that I didn't expect. When I was in secondary education, I actually was not a very good performer, especially in the math and sciences, and a big part of that was because I didn't necessarily understand the connection between math and science. But I was always very mechanical. I've always enjoyed working with machines. And so when I went to the university, I started taking classes primarily in computer science. This is back in the day before computers were like in everybody's pocket. But I took a physics class. And when I took the beginning physics class, it was all about machines and mechanisms. And it was at that point that I realized that this is what I wanted to do in my life, because I finally understood that math was the language of physics. And with math, you could then start to understand the natural world around us, including the mechanisms and motions and the way things moved and the mechanics, the vehicles that I worked on when I was in high school were now understandable to me in a very, very different way. And it was at that point that I realized that I wanted to become a mechanical engineer, and ultimately, was guided in that way through my physics instructor. And that's made all the difference in my life. Not only for me personally as an engineer, but then also being able to contribute as an astronaut, because there's such a wide variety of disciplines within the astronaut corps, and mechanical engineering was one of them.
Okay. I think this role of the multidisciplinarity and the mathematical and physics background in the formation of an engineer, even in an astronaut, is fundamental. And it is not a message that is easy to pass to the students at the age they have to attend those classes. I think that Rui also was an alumni from University of Aveiro, can also comment on the role of this, of the background and the needs for physics, mathematics, and the multidisciplinary background also in the space-related activities.
Yes, I have a similar story to Danny. Since growing up in high school, I was not the crack shot of the class, and this is also something that I always try to confess and to tell students, because sometimes when they're in the early stages of their education at high school, they tend to feel frustrated because they didn't get the highest mark, they didn't get into the course or the degree that they want. I usually say, contrary to many people, that life is long and you can turn around things. And that came about when I came to university. I first went to a maths course, my maths degree here in Aveiro. I didn't feel fulfilled with the abstraction of maths, although it was a great tuition and gave me great background. But I wanted something more applied. I had more or less the same things. When I was a kid, I was taking apart my alarm clock to my parents' frustration. And when I came to university, that click of integrating maths, physics, chemistry, all into something that could be applied was fundamental for me. So I then sought out a degree here in the university. It was engineering geology. I met a very charming professor, Professor Fernando Almeida, who showed me a piece of rock connected with wires. And that's a different way of looking at a rock. And so the next year I changed. I changed my degree. I went to engineering geology. And there the physics made sense. There the chemistry made sense. The maths made sense. So I felt it was fundamental, not just for carrying out my degree, but for my future career as a researcher and as a teacher, and being patient as well with the students that sometimes don't get it at the first time. So in terms of my career as a teacher and as a researcher, it was the education I had here in Aveiro was fundamental. I not only graduated from this university, I postgraduate with a doctorate in this university. I also graduated from the secondary school here in Aveiro. So, and I also learned to fly here in Aveiro. So I'm a product of Aveiro. So I would say that Aveiro has all the ingredients that you can dream to have for being whatever you want in life.
Okay, guys, thank you for this very inspiring, I hope, message for our students and for those that are thinking of coming to university and are even in an earlier stage. I took here some thermal blankets.
Oh.
In fact, I would like to take the opportunity to call attention for another event in the World Space Week, which is an exhibition, Fragments of Space, that you can visit until November 16, I think. That exhibition, we brought this piece that I saw that Daniel already recognized it. And in fact, I would like if you could tell us what is this object exactly, and if it means something special for you, in particular what happened in the Atlantis Shuttle STS-170 mission.
Okay. Well, so the exterior of the space shuttle is protected by thermal protection systems that vary depending on where it is on the vehicle. So, for example, when the space shuttle used to come in, it used to come in basically with the belly pointed towards the planet as it started to decelerate. And because it's going so fast, 25 times the speed of sound, it's coming through the atmosphere. And even though it's up very high where there's not a lot of air, the kinetic energy is so much that it causes the atoms, the molecules of air to basically break up into atomic species. So O2 is typically the way we breathe oxygen. But when it dissociates, it becomes atomic oxygen. And atomic oxygen is extremely reactive. And so consequently, as you have the space shuttle coming in, it's introduced into an environment that becomes extremely hot. Temperatures on the exterior of the space shuttle can reach up to 3,000 degrees Fahrenheit. So I guess in Celsius it's probably about the same. Depending on where you are on the shuttle, you have different thermal protection requirements. Now, it just so happens that on STS-117, when we blasted off and we were going into space, the aerodynamic forces actually interacted with part of the thermal protection system. In this case, it was the thermal blanket, and it wasn't on the black part, the shuttle tiles. It was actually on the opposite side, the top side of the spacecraft. And on my flight, it pulled back part of the blanket. So this blanket here was actually covering one of the engines, and the airflow came and actually pulled back the thermal protection system. And we didn't discover that until we got up on orbit. We got up on orbit and we looked outside, we opened up the payload bay doors and we looked outside, and we could see a corner that looked like it was torn from the blanket. And we needed that blanket because of the heated environment of reentry. The concern was that there was a possibility that what happened 5 flights before on Space Shuttle Columbia, that hot gas would enter into that hole, hot plasma, and then eventually destroy the structure and potentially have a problem coming home. So we took a picture, we took a bunch of pictures, we provided a bunch of data to the engineers on the ground, and then we simply said, okay, you need to help us work on this problem. We have work we need to go do. So we went and we conducted the mission, and then on flight day 6, we were talking to the ground, and they said, okay, we think we've come up with a repair. We want you to, we need the crew to go outside to do a spacewalk and to fix the space shuttle. And then this was now, remember, this is my very first flight, and it was going to be my very second spacewalk. And they said, okay, we want Danny to go fix it. And I'm like, oh my God, why do you want me to go fix this? And I found out later that it was for 2 principal reasons. One is that my background is material science as well. I have a dual degree, mechanical engineering and material science. And I had actually worked with these material systems while I was on, right after Columbia happened. And and then also I think it's because I'm also very much an engineer. I consider myself to be an engineer before I consider myself to be an astronaut. I always tell people I'm an engineer who was fortunate enough to fly in space, because like even today I'm still an engineer. So to me it was going back to like the background, what I love, and that is working with my hands, working with things, with mechanisms and machines and the tactical world around us. And so I went out there, I did the spacewalk, and good news, it worked. I came home. We all came home. But yeah, so that's this is near and dear to my heart.
Daniel, to what extent have those experiences, and of course the view of deep space and Earth from space, change you as a human? Is there any difference between Daniel before the mission and now? How did it change you as a person?
I think for me, so there's a couple of levels. First off, we can only imagine what it's like to be in space. I could only imagine at the time what it was like to be in space. And when I got there, it was that and so much more. It's hard to describe. You wish you could take space and capture it and put it in a bottle so you could bring it back home and you could show people this is what space is like. And it's not just the things that are obvious, like floating in space and eating M&Ms in space. That's fun, right? We can see it on television. But space has sound. Space has a smell. Space, you see space, you feel space, you can hear space. There's so many different attributes about space. More than I could talk about here. But then there's also the emotional connection. When you're 200 kilometers above the planet and you're looking down on the planet, one thing you notice is what you don't see. And what you don't see are us. You don't see the species which dominates the planet. And yet, because we are the species that we are, we create innovative solutions. And we do things that human beings were never meant to do, like living in space. So today, because of human involvement, we have a permanent colony in space and have had it since the year 1998. So we can do some phenomenal things. But then there's also a bit of regret. because as you look down and these same people who you cannot see, you know in your heart that they're down there right now causing tremendous pain and suffering to one another. And you wonder, how can you have such a diametrically opposed a view of a species that is so creative and can do some beautiful things, and yet can do some horrific things to one another. And then you look at the Earth, and what you notice is that the only border that you see from space is that between the ocean and the land. Water and the land is the only distinction you can really make from space. And what that tells us is the things that we fight about here on Earth, like the borders which separate our countries, our provinces, our cities, basically ourselves, are figments of they exist in our mind as human beings, but they're not part of the universe. They're not a rational part of the universe. Differences in our religion, in our points of view of each other based on where we come from, the color of our skin, the words that we speak and how we see them, the gods that we pray to. These are all things that we choose as human beings to make it something that causes us to cause pain to one another, as opposed to work towards a common good. 99.99999% of us are all the same. All the same. And yet we choose to focus on the things that make us different to cause us to be disruptive to one another. And so that's sad. But it's also inspiring because you know that when we all work together, we can accomplish great things.
Okay. Thank you very much. We already spoke here that solar power, oxygen, metals, and minerals are abundant resources in space.
Mm-hmm.
And for instance, as more and more missions are announced, the possibility of mining on the moon moves ever closer. At least we can read about it. In your view, Rui, taking also particular attention to your background,
Mm-hmm.
already mentioned geology here today, how far are we from lunar mining, and what are the main challenges? Do you think that space in general may become one of the sources of raw materials on Earth?
I would place that on two different levels. I think there is the ambition of going outside of our planet and bringing back things which are needed here. But I would think that on a first phase, the moon and other bodies might add, in terms of their resources, are valuable because you need to be there to propel yourself to another stepping stone. So for the moon, I think the utility of resources on the moon first are to establish a colony there. So you would need the materials as building blocks. For example, you would need to find water to survive there. There is no water there. It's hugely expensive to take 1 kilogram, 1 liter of water to the moon. So that makes all the sense to try either synthesize water or find water on the moon. So I think on a first, in the very near future, I think that the resources that we seek on the moon would be for local use. And then on the second stage would be to extract the fuel, the oxygen and the hydrogen, for example, for propellant and fuel. And then only later, I would say, that we would seek out the resources for utility on Earth. Bringing them back will be a huge challenge if we, for example, process them on the moon. We're not even thinking about, as a geologist or an engineering geologist, bringing back the raw materials so that I could process it on Earth would be an enormous task. I think it's not even feasible in terms of the parameters such as re-entry with a few tons of mining ore. So the refinement of the ore would have to be done on the moon. Well, there is already a very interesting resource on the moon, which will possibly be useful for nuclear fusion, which is abundant on the moon. It's not so abundant on Earth. Actually, it's not abundant at all on Earth, so it's from the solar wind.
Yes.
So that resource might be something feasible because it's light. You can concentrate it and bring it back. So I think on a first phase, we would use the resources to establish a colony. Second phase, we would use those resources to propel ourselves to other planets, such as Mars. And then maybe later in parallel, we would bring them back in a refined manner. So that's how I see the resources kind of thing.
Yes, about resources or things that are in space. A very interesting fact is that more than 27,000 of orbital debris or space junk, as is usually common, are traced by the Department of Defense Global Space Surveillance Network sensors. Much more debris, too small to be tracked, but large enough to cause problems, as we already spoke in the beginning of this talk. They exist in the nearer space environment, right? So since both the debris and the spacecraft are traveling at extremely high speeds, an impact of even tiny pieces of those debris with the spacecraft could cause big problems. We already spoke about this kind of events. Do you think that will the increase in this kind of space junk will have an impact in future missions? And now a very particular question, the definition of restrictions regarding the placement of objects in space may limit the space exploration, of course. And do you think that this also may limit initiatives of small countries such as Portugal, for instance?
We have to consider space for what it is, certainly to human beings, and that is, it's a resource. We currently use space in a number of different ways, whether you may think of it on a daily basis or not. We all have cell phones. We all are familiar with communications that we've become accustomed to. We use GPS to help us get around. And these are just some of the resources, things like weather, observations, planting for crops, looking at tidal surges, looking at the Earth, let's say post-disasters. These are all ways that we currently use space that we don't necessarily think about. And because of that, we have to consider space no different than any other resource that we have here on Earth, and it has to be conserved and protected. Now, the issue that you're referring to, the orbital debris, is a consequence of us actually going to space. We go into space, a rocket body, detaches from the payload, which boosts up to a higher orbit. That is junk that just stays up there. There's no way to bring that back. It gets trapped in orbit if it's not at a high enough altitude, if it's at too high of an altitude. There's also satellites that become inoperational because they run out of battery life, or they have some problem with the computers, or they run out of fuel. And then there's all the other things that's up there, which could range anything from paint chips, very, very small, tiny things, to bolts and nuts and washers and all sorts of things. And then there's the additional types of debris, which are things that are a result of what we refer to as conjunctions. So collisions between two bodies creates now more debris. So maybe two satellites run into each other, which already has happened. The Iridium satellite ran into a Roscosmos defunct satellite back in the 1990s or so. And then there were two ballistic tests where countries of Earth shot down satellites, and then in the process, to demonstrate that they could do that, created enormous debris clouds. All this to say is that, yes, debris is a very big issue. Now, NASA has embarked on an accord to try to bring attention to the responsible use of space, and referred to as the Artemis Accords. And NASA is actively trying to work with other countries to sign agreements to basically is a pledge by the country to minimize the impact that we have when we go into orbit. And that means minimize the amount of orbital debris which is created, to not create debris on purpose, and to deorbit satellites, and to have a plan for deorbiting satellites in a more effective and time-efficient manner, rather than 10 years, which is what it used to be. Now it's 5 years. And then there's a bunch of other things with regard to respecting countries and other organizations that put satellites into space. So I do believe that Portugal has a role to play in there. I think every country, even if they're not spacefaring countries, have an ability to sign up for that as a global community, to say we believe that this is the right thing to do.
Even in this context, how do you see the role of new space, also known as private space flight, in terms of enhancing the rate and development of space exploration in the future?
Right, so new space is actually very interesting to me because it represents the greatest opportunity for entrepreneurs, for young engineers who have ideas. Old space is the old traditional really big rockets, and they carry large satellites into orbit. We now have the ability, because of microelectronic technology and computer technology, we have satellites that are literally 10 centimeters by 10 centimeters by 10 centimeters, one CubeSat. And that is a satellite. If you've seen Starlink, for example, SpaceX has launched a series of Starlink satellites. They put them into orbit. These are CubeSat designed payloads. And that represents a tremendous opportunity. But it also represents a tremendous responsibility, because now you no longer have just companies, or government agencies launching satellites into space. You now have private companies that have the ability to do so. And there's not, just like the bus is a government entity, which they know where the bus is going to go every single day. When you get into your car, that's a private car. You can go anywhere you want to go. Something similar in new space. If you have a commercial enterprise, you're going to go into space. What you do in space is pretty much up to you within certain restrictions. But new space does represent a great opportunity, but it also represents the potential for risking the things that we really know could possibly happen from that.
Before the last question, and just to let you know, while preparing this talk here, I spoke with some students, also some colleagues, and attending to your background in material science, also engineering, someone posed a very specific question about additive manufacture.
Mm-hmm.
And in what concerns material processing, what you think will be the impact, and if it already has some real impact on special missions, the question of additive manufacturing.
Well, I think we can speak about this as well. Being able to manufacture from the resources that you have available to you is extremely important. The great thing about additive manufacturing is that you don't have to have a concept today of what the design needs to look like. So consequently, your tooling doesn't have to necessarily be as well defined. And being able to use natural resources, like when they looked at this both at Mars and on the Moon, the idea of having some sort of additive manufacturing capability. Additionally, if you're going to go on a long duration space flight, let's say to go to Mars is going to take you 7 to 9 months, right? Just to get there. And what happens if you either break a tool along the way or need a tool as you go out? One thing we've known about space for a long time is, despite how much we know about it today, it always surprises us. And so we have to be prepared with options. And so, I don't know, Rui, what are your thoughts on 3D manufacturing on the Moon?
Uniqueness.
Yes, of course, because on the Moon you could fabricate the habitats with robots, and that would aid tremendously, because lunar dust is a big hazard for astronauts, so you would avoid the astronauts having to go into that dusty environment. Those problems, for those who are not so familiar, caused eye irritation, some irritation even in the throat and lungs. So lunar dust can be hazardous. So if you have a robot, a 3D printing robot that could make a habitat, that would aid. So that's how I see it from a mining perspective. On an astronaut perspective, you just have to think of what would have been Apollo 13 if they had a 3D printer. They needed to adapt with duct tape and plastic bags, the CO2 canisters, which are actually made from lithium hydroxide. So if they would have had a 3D printing capacity at that time, they could have designed it on Earth, uploaded to the Apollo command module or the lunar module. They could have 3D printed a solution to fit the canister. So if you haven't seen Apollo 13, see the CO2 issue during what happened in the film with Tom Hanks, or you can see it in the documentary. There are quite a few documentaries with Jim Lovell speaking about it. So.
I would encourage all students to even play with the technology. You don't have to be a mechanical engineer to actually work with 3D printing. It's a little bit of coding, not a whole lot. You can even download designs right off the web. I go to Thingiverse. I have 2 printers at home, by the way. You go to Thingiverse and you can download them, and you can go to either a print shop or buy a small, inexpensive printer yourself. It sits on your desktop. You have a little bit of plastic PLA or ABS plastic wire that feeds into it, and you can make toys like fidget spinners, and I've made brackets for my own home. I made tools, and just to kind of understand kind of what the possibility of it. And I think one thing I'd also like to add is that one of the ways you get to innovative solutions is by knowing what the capabilities are of the instruments that you can use. And I think when students go beyond, let's say, their area of expertise and try to like play a little bit with coding, play a little bit with 3D printing, play a little bit with electronics, they start seeing the world in a different way, and they can start to come up with much more creative solutions than if all they do is simply study one particular discipline.
Oh, we are coming to the end, but taking your final words, and we are at a university where our main mission is the students that are looking at us, the formation of human resources. I think that from this talk, and please correct me if I'm wrong, it is very clear that we can do anything or we can do everything just as long as we have a very nice and solid background in physics, mathematics, in science in general, and then it's up to us to decide our future. In many ways, society is formative. We need to have courses, we have to have names for the courses, we have to have subjects. And if you have, and here I have the chance to have an external view and an internal view for the future in terms of formation, which should be the courses, at least for a second cycle formation, in which universities should invest so that we can, of course, I will ask in this area for space, but in general, engineering, if you have to decide or to help decide the future of formation at university, do you have any comment in addition, what will be the specific areas in which we should think for the future jobs that we may not now even think they will be?
Well, I'm going to give an answer which is basically based on what I felt when I graduated. When I graduated, I said, well, what do I know what to do? And I couldn't pinpoint exactly what I could do, but I could decide, I could say something. The whole tuition in engineering that I got was specifically directed to engineering geology, taught me how to solve problems by myself and to look up and to go to the bibliography and, and consult and develop if I didn't know, because sometimes you get problems which nobody knows. So I think basically university gave me the tools to find out by myself and to discover by myself. Of course, it's essential to have certain key aspects of your specific formation, but if you have a good, solid background, as I said, in maths, physics, chemistry, and also the other subjects as well, all the other subjects, I think it teaches you to solve problems. But above all, a student should do what he loves most and be good at it. So if he's good at what he does and he loves it, I think nowadays you see a lot of disciplines which need to talk to different backgrounds. And one of the other thing I appreciated while studying here was the ability to, after lunchtime, I would go to the cafe outside, and you would talk with a colleague from the language department. You would talk about French literature, or then you would have a friend, one day you'd have a chat about ceramics. So the good thing about this campus, which is also valuable, you get to know your friends who study in the most diverse fields. And so if I have any advice, be a sponge for those things and enjoy yourselves and enjoy knowledge.
So I have probably two answers. First answer is a technical answer. Based on where I see technology today, I think the broad views of, for example, coding is an important technical attribute to have regardless of what discipline you go into. And we're living in an ever more computer integrated society with AI, machine learning, and Internet of Things and whatnot. So having some coding background is important, just at least you understand how things are working and being commanded. And then the additive manufacturing, I think, is also an important attribute as well, because I think that is something that is the next generation of how we're going to continue to do things. And actually, the two are overlapping. So that's more of a technical answer, but I think the more philosophical answer for the students is that I believe that there's two things that you need to be successful in life, and that is you need to work hard and you need to never give up. Technical classes, actually all classes, things that you don't know and that you're learning are going to be challenging. Whether you're talking about French literature, which would be really tough for me, or physics, they're going to be challenging. But the way you learn and the way you can be successful is through hard work and perseverance. And by working hard and not giving up, regardless of how you perform in those classes, you learn now what doesn't work. And you learn what you need to do to be better. And it could be you didn't apply yourself hard enough, you approached the problem in the wrong way, you stayed up too late, having a good time, or maybe you just completely missed the concept altogether. But by being committed to that and saying, okay, this is what I think Rui and I are talking, is like we struggled in school, but we never gave up, and we continued to apply ourselves. And I always tell people, I'm not the sharpest tack in the box. I'm not a bright person. I don't consider myself to be smart or intelligent or anything like that. But one thing I do know is that I work hard. I work hard every single day. And I can compensate for not having a very high IQ or being, highly intellectual by applying myself. And I think through that, anybody can be successful. Anybody can achieve whatever you want through hard work and perseverance.
Okay, I think these are the right words to finish. So thank you very much once again for being here. And although you cannot see it, thank you also for this fantastic audience that we had also here in presence. Thank you very much for everything.
Obrigado.
Obrigada.
Obrigado.